In this video, we will cover the review exercise number 2 at the end of tutorial 2 on pages 172 through 175 in the text. I highly recommend that you take a little time to first look over the drawing and read the instructions that follow, as these are the guidelines I will use to grade the assignment. Looking at the drawing, we need to take note of where our origin is, where our stock is, the center line. We may want to go ahead and quantify that right off the bat, because we're going to use that to rotate around as an axis as well. And just take a look, as with any drawing, when you first approach it, you want to look to see if there's a series of rectangles and lines, both parallel and horizontal, and angular lines. And sort of divide that up and pick the ones that are going to give you the most pictorial value first. So first we'll start with the large rectangle, which is 8 by negative 3.25 in the Y. So we go to our create rectangle, and it's 8 by negative 3 1/4 in the Y. Enter. Here's our phantom, and we are going to place that right on the origin as depicted in our print. We can do a fit then, and mouse wheel it down. There's another rectangle. I would advise making it the entire distance of the part, because we can use the remainder of that distance to parallel from. So in that sense, and this is exactly how we did it in tutorial 2, we want to create another rectangle. First I will apply this large one. My next rectangle is going to be 6 inches in length, and it's only going to be a full shaft diameter 750, so we're going to make half of that because of our revolving. So it's going to be 375 in width, and we'll go ahead and hit enter to get that phantom. It looks right because basically it's half of our shaft. And then I'm going to go up to fast point. We have a print dimension of 1 in the X in terms of location, and in the Y, as I instructed earlier, to go ahead and calculate the Y location of that center line, and it is negative 1.625. I wrote that right on the print. I'll use it again when I put my hole in, and I'm going to use it for the axis to rotate my part around. So that looks good. Basically it's placed on the center line. If you just hover on these, you can see those are your center points, and that it does align with those. So that looks like it for rectangles. I'm going to check out of that command. Now I'm going to start putting in parallel lines. I'm going to start with the vertical ones because they look like they'll give me the most pictorial value to help me build my part visually. We're going to go to parallel lines. I am instructed to select a line. I'm going to parallel off of this line. My amount will be from print 3.625, 3.625, enter, and then it says indicate the offset direction. It is this direction. I'm going to accept it, but stay in the command. I'm going to select another line. I can use either this one or this one. I'll use this one. Select the point to place it. It's at 1 inch per the drawing, and it's on this side of the line. I've got a couple more I can use for my head, or at least one more. Select a line. I'm going to select from this right side of a distance of 0.75, 3/4 of an inch, enter, and it's going to be on this side, and there's my head. So I think that's it for parallel lines in terms of vertical, but I can still make my horizontal ones. It looks as though I've only got 2 of them. We're going to come off the center point of the part. That's where everything's dimensioned. My distance, if I'm going to do the head right now, it's 1 1/4 inches in diameter, but that's divided by 2. 0.625. That's 5/8. The offset direction is here. So now I just put in the edge of the head. I'm going to accept that one. And then I've got another one that is the flat shoulder. It's 1 inch in diameter, so select the line, indicate the offset direction, which is 0.5, enter, and now indicate my offset direction. And I believe that's it for parallel lines, so I'm going to exit out of that command. Now I'm going to start to draw my part through trim and extend as much as possible at this point. You can go to the scissors. I'm just going to use the trim one entity. This will also extend, so if I say I want this line to go all the way up to here, it'll do so. This is the other end of my head, so this line needs to trim and or extend up to this line. I don't need any more of this, so I'm going to keep this much to here. This line has nothing to do with the head, so I'm going to trim that out just so I can see it better. We'll keep this line to here for now. And we'll keep this line to here for now. So I've got my head, and then I've got my next shoulder drawn in. At this point I may want to put my angular lines in now. So I'll check out of that and go to just create line endpoint. I'll look at that 45-degree angle I need to put in, sort of a chamfer. Specify my first endpoint, which is here. It's not going to be tangent, horizontal, or vertical. It's going to be an angular line. 0 degrees starts at 3 o'clock, 90 degrees is at 12, 180 is at 9, and we need another 45. So 180 plus 45 is 225. 225, enter. And all I really need to do is place it across my intersection, which should be this line. So that looks good. I'm going to apply that, but stay in the command. And I've got a 7-degree line to put in. So I'm going to change to 7 degrees. And specify my first endpoint. If I look at my print, it's at this shoulder here. 7 degrees right off the 3 o'clock, so I'm good. All I need to do is cross my intersecting line, put my 7 back in because it didn't hold, and I'll just back it up to where I cross my intersection, which is there. And that's good for my line endpoints. Now I can trim some more. Pick the scissors. I only need the 7 degrees to go up to here. I only need this line to go to the angle line. I want to trim this line. I want to keep this to the 7 degrees. The 45 I want to keep to this flat. I want to keep this flat to the 45. And I only need this shaft to here. That looks really good. Now I can delete all of these. You can either hit your delete button or the eraser. And the last thing we need to do is put in our fillets, which are 0.0625 radius. So to put those in, we go to our fillet command, put in our radius 0.0625, and follow the prompt. Our drawing says we need a fillet at this corner and at this corner. Those look correct. I'm going to check out of that. And the last piece of 2D geometry we need to put in is the hole. So we go to the Create Circle Center Point command, put in our diameter, which is 1/2 inch, enter. We've got our phantom hole. Now we can place it through Fast Point by putting in the location. The X direction is right on the print. It's 5.5, comma, and it's right on the center line, which we've determined is negative 1.625 in the Y. And hit enter, and that hole is placed. And it looks correct according to our instructions. So now we can go ahead and start creating surfaces and building the rest of the part from those. The first one we're going to do is the revolve. Create, surface, revolved. Leave the chaining dialog box the way it is. Go up to our prompt. It says select a profile. So we will select the chain to begin here, go follow this profile, and we'll end it here. Because we're not going to revolve this. This is simply our center line, and it's going to serve as an axis, which you'll see. So when I say OK to that profile, it says select the axis of rotation, which is this, and there we have our rotation. Go to isometric, and you'll see that it rotated the entire 360 degrees around. We really only need 180 degrees for this job. Hit enter, and it gave us the correct 180. I'm going to fit it. You can also use this flip button if it gave you the wrong one, but that's what we need. So now we're ready to move on to the hole. We're going to place that hole onto the surface. So I'm going to go up to X-Form, Project, it says select entities to project. I'm going to pick this hole, hit enter or end selection. We want to move it, but we want to move it onto a surface. So we hit that icon. Now we pick the surfaces as we are prompted. That one and that one. There's a little trick they threw us. We have two surfaces. End selection. And it looks like it projected very well. We don't want to join results because we need to use net later. And net needs the results not to be joined. It needs a minimum of 3 entities. So the rest of that box looks good. I'm going to say OK, and there's my hole projected onto the part. Moving along with our instructions, we need to create a draft surface. Create surface, draft. We can leave chain on, but we're probably going to have 3 chains. I'm going to pick that one. Oh, it chained everything, but there's still 3 elements in there. Say OK. According to the detailed drawing on the print, the depth is 0.125. Enter. The direction looks good. At an angle of 45 degrees, hit enter, and that angle looks good as well. Say OK. Anytime we do a draft, we need to put some edges on it. To do that, we go to Create, Curve on Edge. I'm going to roll up on this, pivot it, roll it up some more. You can also use the zoom target command like we did in tutorial 2 if you like. So it's prompting me to select a surface. I'm going to pick this surface. When you hover over them and they light up, then you can pick them. Now without holding any buttons down, I'm going to slide the mouse down to the edge that I want and then click. See, my edge was created. We need to accept that one. We need to go to this surface, pick it, slide down freehand, and click. There's the edge created there. Accept that or apply it. Select a surface. This is the third one. Pick the surface, slide down, and click. And those are all of our edges that we need. We can check out of that command. Now we have something on which to place a net, which is another type of surface. This would be a good time to change colors. You can change colors on every surface if you like as well. It's probably a good idea because you can use it for masking and picking things, and also visual reasons. I'm going to go to blue, and I'm going to create a new surface using the net command. Here I need to go to elements because it needs 3. Now you could use chain if you had a lot of chains, but because I need 3, I need to go to single, 3 minimum that is. Select chain, pick this surface edge we created. I like the clockwise direction. Select another one. It's this little edge here we just created. I'm going to reverse the direction. They should all at least be going the same way. And then I've got a little surface edge I put in right here. Reverse it. And those are my 3 edges. And it created the net. And the net looks correct according to our instructions. I'll shade it, but yeah, it doesn't show up because we haven't created a demarcation from the Revolve surface yet, but it looks good that way. So now I will do a fit and a clear colors. Okay, so now we need to put in that fillet on that hole. Go back to wireframe. You can also do alternate S. I'm going to move it around so I can get in there. So to put the fillet in, I go back up to Create, Surface, Fillet, 2 surfaces, and carefully read your prompts. It wants them in sets before we hit End Selection or Enter. So my first set includes this surface, and that one, and that one. Now hit Enter. The second set of surfaces includes this surface and this surface. Hit Enter. My fillet radius is 0.0625 per the detail view on the print. So that's correct. Let's take a look. No fillets found. Okay, we have to play with the arrows. Hit the flip normal button. I only want to change one set of arrows at a time. I'm going to start with the easiest one and flip the Revolve surfaces. Hit Enter. There it worked. Generated our radius. So we will accept that. And I'm going to shade it just to see what we have. It looks good. It's a little bit visually off, But I'm not going to fuss about that until I see how it cuts. If it doesn't cut right, then we have a problem, but I can't imagine anything going wrong here. Looks like we did everything pretty well. Now we can put in our flat boundary surface. Isometric and fit. Create. Surface. Flat boundary. Chaining dialog box. Pick this chain. Say OK. And accept it. And that's our part. We do need a bounding box, however, so that we can place the top of the part, which is like the tangent point of this head here, onto a 0 position in the z-axis. So our bounding box helps us do that. It's kind of like when you buy a randomly shaped item and they give you the overall dimensions of length, width, and height. That's kind of what a bounding box does. So let's create one. It just bounds every extent of the part that it reaches. Make sure you don't have points selected here, and that's okay. So now we've got a bounding box, and from that bounding box we can place our part on Z0 now. And we just go to X-Form, move to Origin, and pick this intersection. And we're down on Z0. When we create our stock, then we will add 200 thousandths to the Z top, and the machine will know that that's there for when it tries to do rapid and start its feeds. So it's time to pick a machine and set up some stock and cut this part. So having picked our standard default machine, looking at tool settings, this is job number 4. All of these settings are the same old standard. Set up our stock. We pick our dimensions off the print, which is y 3.25, x 8, and z is 1.25, which is shown on the side view. And then here's where we add our 200 thousandths to the z, and this is where we tell the machine that it's there. We want to turn on the wireframe so we can make sure it looks okay. Say OK. There's our stock, and that's what the machine knows is there. So we can start creating toolpaths. The first one would be the surface rough pocket. Toolpaths, surface rough, pocket. Put your name in here, and this is my information that tells me what job it is. And that will show up in the program, just like the verbiage that you put in with the tool in terms of what we're doing. So now we select the drive surface, which is the whole mask. We can either box it or pick the QM. And selection, we do need a containment boundary here because it knows not to go onto the shaft, but it doesn't know that it doesn't need to go completely around the world. So we need to contain it within that cube. And so we just pick, you can't select stock, so we pick our 2D chain here and say OK. And that's good. We don't need anything else to go with that. We need the 1/2-inch bull end mill with the 0.625 radius. Make sure it's a bull end mill, not a ball end mill. Bull end mills have flat bottoms and then defined radiuses. A ball end mill is spherical, and you might see it called that in the tool library as well. They go back and forth. Tool number 1, and here we're going to rough the pocket. That way, if there's multiple roughing pocket commands in the program, you'll be able to see which one it is. Next we go to surface parameters. Stock to leave on drive surface is our standard 30 we've been using. Enter. These are our standard parameters in terms of clearance and retract and feed plane. They're described again on page 148 if you want to check those out another time. It takes a while to understand these definitions, and as you build the context, they'll become clearer. Now we go to rough parameters. This is the same thing as working through our tree view list in 2D. It's actually simpler though because the machine's more intuitive. We really just have to tell the cutter how we want it to do things. These parameters are explained on page 149. Total tolerance is 10 thousandths with a step over of 50 per our instructions on page 176. We're not going to use the helical entry this time. We are going to plunge outside of the containment boundary and then start working our way over that way. So we're going to come in from the side, is all that's saying. And then we go to pocket parameters. These are defined on page 150. Cutting method is parallel spiral. Step over percentage is 55%. It's already in there. Of the diameter, which is checked. And then disable this finish. And let's take a look at that. Okay. Backplot. Fit, isometric, and run it. Geometrically everything looked good, and I don't see me cutting a lot of air, but I'm going to verify it and step it through just to make sure. Not a lot of air being cut there, so we can go ahead and keep that operation. It looks good. Close that window. Clear colors. Looking at page 176, our next operation is finish the part using surface finish parallel toolpath. So we go up to Toolpaths, surface, finish, parallel. It's asking us to select a drive surface. That would pretty much be everything. So we'll use the QM surfaces and selection. We don't need a containment boundary on this, so we can click OK. We're instructed to use a 1/4 inch ball end mill. Because I practiced, these are already available to me. And we're going to say finish the part. Move on to surface parameters. We're not going to leave any stock. These are going to be set the usual way, so we can skip right over that one. Now the finish parallel parameters are described on page 159. We are instructed to use a total tolerance of 1,000th, maximum step over of 10 thousandths, a machining angle of 45 degrees, and a cutting method of zigzag. Also, they want us to look into the gap size and set a gap size of 300% of step over, which our step over is only 10, so this would be 30. A tangential line length of 0.2, and this is basically where we will go off the part while we're going back and forth at 45 degrees. These are described on page 160. And that's everything for that operation. At this point, I think I'm going to select all. You can see only this one's selected, but I need to have it roughed out before I can really see. So I'm going to select all and go straight to verify. And run it, because at this point I want to see the result. I can speed it up. See it cutting on a 45 angle, and then it's going off the part by 0.2 as well. That's the result I want according to my instructions on page 176. And at this point we really just need to pick out the corners because we used a 1/4 inch end mill on that and it can only get so close. Close this window. Toolpaths, surface finish pencil. Select a drive surface. We can mask the whole thing. I'm going to show you how the box works as well. We selected everything. End selection. No containment boundary on this. So just say OK. We're instructed to use the 16-inch ball end mill. And we're going to finish the corners, the sharp corners. Tool number 3, everything looks good. Our surface parameters are the standards. We're not leaving any stock. We'll leave it on center in terms of the machine's calculations. And then we need to do the finish pencil parameters. These are defined on page 167. Total tolerance is 1,000th. Parallel passes, meaning we don't want to take it all off in one cut. So we're going to do it in 4 passes of, and this is in your instructions, 10 thousandths. Enable negative and positive motion along surface. That allows it to cut while it's feeding in or approaching. If necessary, it's a little more efficient. We want the zigzag cutting method and a bitangency angle of 165 and an over thickness of 0. Again, these are defined on page 167 and I really can't explain them at this point myself. Say OK. Select all. Verify. Here's our 3 operations: the rough pocket, the finish, and the pencil. I'm going to leave it on fast because this is going to take a while. I mean, if we ran it slowly, there are so many lines of code here. That is a good looking part. See, that's just a visual deal there. Nothing to worry about. So, you get out of that. Look at our part this way. Everything looks good. You can turn it into me exactly like this. I'm going to go through these operations and check all your forms and make sure they're filled out correctly. And I will run the verify slower so I can make sure it's cutting the way we instructed it to per the instructions in the text. So good luck.